Bowman's capsule. Bowman's capsule is a expansion at the closest of the renal tubule, called at the beginnings of the tubular component of a nephron. In the mammalian kidney that performs the first step is the filtration of blood to form urine. Anatomy. Outside the capsule there are two poles. The vascular pole is the side with the afferent arteriole and efferent arteriole. The urinary pole is the side with the proximal convoluted tubule. Inside the capsule, the layers are as follows: from outside to inside: parietal layer, epithelium, Bowman's space, visceral layers, filtration barrier. Bowman's capsule description. We can see a video.
We're looking at the Bowman's capsule. This is the glomerulus inside of it. As we're looking at it, we see there's blood vessels or arterioles on one end. So we know that then the opposite end is going to be the proximal convoluted tubule, and that is in pink. So then we know that the rest of the cross sections that are in pink are portions of the proximal convoluted tubule. We go back to the opposite end where the arterioles are, and we see that next to it is a cross-section of the distal convoluted tubule. Now we need to figure out which of the arterioles is the afferent and which is the efferent. The afferent is the one that's going to be closer to the macula densa, where we see closely dense cells. They become closer together as compared to the rest that are spaced further apart. We also see these yellow cells that are the JG cells, and both the macula densa and the JG cells become the JG apparatus. So this is going to be the afferent, this is going to be the efferent. When we look at the actual inside of the glomerulus of the capsule, this is the visceral part of the glomerulus. This here is the parietal part of the glomerulus. The visceral part, as we look closely, we see little indentations that look like little fingers going around, and those are the pedicels. What's not shown on this model is little cells that might be little oval-shaped cells that are usually in blue, and those are the podocytes. We also see cross-sections of the collecting duct, which is marked in yellow. And that's the end of that.
Renal capsule locations. The capsule is found to surround the outer walls of the kidney. It is found to enter into the sinus, a hollow area of the kidney. It connects to the major ducts, veins, and arteries inside the sinus. Renal capsule functions. The membranous structure protects the kidney from the possible damage and injuries. It also helps support the weight of the organ. It lines the wall of the sinus. The capsule gets its blood supply from the intervalvular vessels, or tiny vessels that are from the primary renal arteries. We can see a video. The rate of the filtration is approximately 125 millimeters or 45 gallons each day.
Artery that goes into the glomerulus. Okay, now substances that are easily cleaned at this level with just the glomerulus without concentrating into the proximal convoluted tubule for further degradation or filtration. These podocytes, that's what these are, podocytes, are macrophages, and the material coming into the glomerulus, these macrophages take care of all the bad stuff that's small enough for them to handle first. Then it can recirculate back through the efferent artery back into circulation. This is the afferent. It's larger than the efferent. Okay? Now, this is known as the glomerulus, and it's surrounded by a capsule known as the Bowman's capsule. Okay? Together, the Bowman's capsule and the glomerulus make up the renal corpuscle. Okay? Now, for further filtration that needs to go through reabsorption and filtration in a more complex form, the fluids will travel through the proximal convoluted tubule that we see here, proximal convoluted tubule, through the descending limb, loop of Henle, ascending limb, distal convoluted tubule, into the collecting duct. The collecting duct at this time, after the filtration takes place here, is going to have pure urine. And it's going to transfer that urine down to the renal papillae, which are right in here. Renal papillae at the apex of the pyramids is going to drip pure urine into the minor calyx, from the minor calyx to the major calyx, from the major calyx to the renal pelvis, into the ureter, and then down into the bladder. Okay? So you have approximately 1 million nephrons per kidney. Nephrons reside in the pyramids. Now the space that the pyramids reside in is called the medulla. From the base of the pyramids to the renal capsule, or fibrous capsule, is the cortex. Okay? In between the pyramids are known as the renal columns. Okay? Columns are a tissue that separate the pyramids from each other. Okay? The depression in the kidney is known as the hilum, and the hilum is the area where blood vessels, nerve tissue, and the ureters will enter and exit the kidney. The way to tell the difference between the cortical nephron and juxtaglomerular nephron is that the juxtaglomerular nephron has larger descending and ascending loops than the cortical one does. It's shorter. Also, the cortical nephron is closer to the cortex, and the juxtaglomerular nephron is closer to the medulla. So another thing here is the juxtaglomerular tubules are going to be deeper into the medulla than the cortical tubes. Okay? And they are longer. Juxtaglomerular nephrons are longer than cortical. Corticals are shorter. That's how you can tell. Okay?
Clinical significance. Measuring the glomerular filtration rate, a diagnostic test of kidney function, a decreases may be a sign of renal failure. A number of disasters can result in various problems with the glomerulus. Example includes acute polyphasitis, endocapillary glomerulonephritis, mesangiopolyneuropathy, glomerulonephritis, mesangiocapillary glomerulonephritis, acute crescent glomerulonephritis, focal segmental glomerulonephritis, and diabetic glomerulosclerosis. Structures.
Really what we did is we blew this up so that it's much larger. So again, the outer capsule, the cortex, and the medulla. So the dark red here is the pyramids. And you have two nephrons that are being represented here. One is known as a cortical nephron because it's about half cortical, half medulla. But this one here is so much more in the medulla. Okay, this is what's called a juxtamedullary nephron. Okay, this is the one that would more likely be involved in diluting and concentrating urine. because it's going so deep into the medulla and there's concentration changes. Okay, so this is cortical juxtamedullary. The blood vessels on here, interlobar, arcuate, interlobulars. Now what's going to happen from the interlobular is your vessel here, maybe hard to see, is the same as this one, is an afferent arteriole. Just think like with the nervous system, you had afferent neurons that brought things into the central nervous system, and efferent that took them out. This is the afferent arteriole, this is the efferent. So in here, the afferent goes into the filter. It goes into the glomerulus. All of this is the glomerulus. It's actually the renal filter. Okay, and because of pressure changes, you can actually, the difference between inside the blood pressure and other pressures in the capsule, okay, you actually filter off blood into the capsule and into eventually the proximal convoluted tubule. So what happens here is pressure changes allow these capillaries to work as a filter. Now everything will get filtered except medium and large proteins and blood. If you see blood in your urine, there's something wrong. It's not a normal thing. Obviously, unless you were using some kind of urine analysis test strip, you wouldn't know if there was protein in the urine, chances are. Okay, but medium and large proteins should not get through the filter. Okay, blood shouldn't get through the filter. The blood cells are too big. Everything else will get through. Water and sodium, glucose, potassium, amino acids, urea, uric acid, all the waste products, obviously, creatinine, urea, uric acid, ammonium ions. And as we'll see in lecture, various things get put back into the blood and various things go out in the urine. So these vessels here are afferent and they go into the glomerulus. So afferent into the glomerulus. The blood that's now been filtered comes back and goes into this here, into the efferent with an E, taking it away, arteriole. And what happens with the efferent arteriole is the following. It'll either go into these peritubular capillaries or vasa recta. The peritubular capillaries, they wrap themselves around the tubules. Peritubular, around tubules. Okay, and the vasa recta means straight vessels. They just go way down into the medulla, okay, and they're going to be there to concentrate and dilute the urine. Eventually what happens is that all of this will come back through interlobular veins here, okay, arcuate veins, interlobar veins, segmental and renal veins, taking us stuff away from the kidneys.
Treatment for kidney failure include dialysis or transplantations. There are two major types of dialysis. In hemodialysis, blood is run through the external filter and the clean blood is returned to the body. Hemodialysis is usually done at dialysis center 3 times a week. Peritoneal dialysis used to the lining of your abdominal cavity, the space in your body that holds organs like the stomach, intestines, and liver, to filter your blood. This kind of dialysis is needed daily, but it can be performed at home while you're asleep. A kidney transplant is an operation that places a healthy kidney in your body. The transplanted kidney takes over the work of the 2 kidneys that failed, and you no longer need dialysis. Counts for disease. Diet, sodium-free, fistula in the arm, dialysis at the week. It is the complement with the heart disease. If one or both kidneys fall completely and the damage can be reversed, the condition is called kidney failure or and stage renal discharge. We're going to see the last video, urinary formation process.
Urine is formed by 3 processes in the nephron, the functional part of the kidney. In glomerular filtration, the glomerulus filters water and certain dissolved substances from the plasma of the blood. This results in increased blood pressure, which forces the plasma-like fluid from the blood into Bowman's capsule and then into the tubules. The fluid or filtrate include many positive and negative ions of many elements. The filtrate does not have any proteins or red blood cells, which are too large to pass through the capillary membrane. In tubular reabsorption, substances are transported out of the tubules and back into the blood of the peritubular capillaries. Reabsorption takes place in the proximal tubule, loop of Henle, and distal tubule. The major part of reabsorption occurs in the proximal tubule. About 15% of water is reabsorbed back into the bloodstream. The process is regulated by the hormones vasopressin and aldosterone. In tubular secretion, substances move from the plasma in the peritubular capillaries back into the filtrate in the renal tubules. The proximal tubule secretes creatinine and histamine, and the distal tubule and collecting duct secrete potassium into the filtrate. All the tubules actively secrete hydrogen ions to regulate the pH of the body fluids. The filtrate is now urine. Urine is about 95% water with a balanced urea, uric acid, amino acids, and electrolytes. The daily production is about 0.6 to 2.5 liters per day. Urine production below 30 milliliters per hour indicates possible kidney failure.
It was all.